Now continue from previous video where we look at the option 1, the requirement of the reinforcement. We try option 1. Now we can check the option 2 and option 2 against the AS3600 requirement. Now just a quick notes for option 1 that we found the KU value was 0.239. I think I can just find it out for you where the KU value where we calculated 0.239. So we can just check against the Australian standards, which is require less than 0.36 for the singly reinforced design, and which was generally recommended to have a under reinforced singly reinforced beam. So it is less than 0.36, so we don't need to provide any compression reinforcements. And if you go to clause 8.1.5, which I can show it to you here. So clause 8.1.5 is recommending this KU value. So it should be used when it's greater than 0.36. We need to provide the compression reinforcement, but our value is less than 0.36. So for that case, for options 1 we can adopt only tensile reinforcement, which is 2 and 20 bars. Now options 2 has, if I go back to the last video where we have option 2, we have an option 2 taking 3 bars with N 16 millimeter dia bars. Now if I put those 3 bars at the bottoms, 2 on the sides and 1 in the centers, I would need to find the space available, that gap available between two reinforcements. Could be, let's say cover is 25 millimeters. I think in our discussion in the last video we have recommended this for durability. We have a minimum cover of 25 millimeters. So we are providing 25 millimeters cover for top and bottoms. The stirrup is 10 millimeters, and then diameter is 16. Let's say we need to find this x distance, then 16. We need to find this x distance, and then 16 plus stirrup diameter 10 plus 25 equal to 150. So that is the width of the beam, 150. Now if I just add them together, that will be 2x plus 118 equal to 150. If I just bring this one across, become 32. So distance x basically is 16 meter. That's the gap between two reinforcement. Now that is the available spacing with this reinforcement. Now in the last video I said that AS3600 does not provide any spacing requirement, but then I just had some book read where I found this old standard AS1480 1982, very old standards. I tried to search for this standard, but I could not find the copy right now with me. But in the book it says that this is very old, but still it can be used as a guide, that minimum spacing that you should provide for the beam should have a maximum value between these three, which is, let's say, 25, and this is a diameter of the larger bar, so diameter of the bar that you're using, or 1.5 times A, which is the maximum aggregate size. So if I just find it out, what would be the minimum would be 25. Diameters is 16 millimeters bar diameter for option 2, and 1.5 times aggregate size. I think we have a let's say somewhere we written the aggregate size. Yep, we have an assumptions tree where we take the assume maximum aggregate size A equal to 20 millimeters. So we put these 20 millimeters here, so that is gives 30. So if I take the maximum value 30 millimeters is the minimum gap that we should provide. That is just a guide for us to have a reference value. As I mentioned, with the practice you need to provide that minimum, and AS3600 does not recommend, but at least we need some guide for this example. Therefore I just have 30 millimeters by this reference. So 16 millimeters is less than, sorry, this one should be less than. So 16 millimeters is less than 30 millimeters. So that is not okay. We need to have at least 30 millimeters. We should have more than 30 millimeters gap. So option 2 is not acceptable. So if you look at the option 1 where we have a 40 millimeter gap, that was acceptable. That is satisfy this requirement. So option 2 is not acceptable because it provides the conjunction. It has fulfilled all the requirement, but it will provide the conjunction for the concrete compact and concrete pouring. So option 2 is not acceptable. Now similarly option 3 is not acceptable because option 3 even more conjunctions. I did not provide the calculations here, but if you provide 4 bars with the 20 millimeters diameters, of course it will have a less spacing available and it will not be acceptable. So we are just going for option 1, that we're going to take it. But the option 1 should have a couple of notes here. Now this finish the examples here, we don't need to go further, but this is just for the practical purpose. In the structure engineers, when you work in the somewhere in the consulting firm, you might need to have some background knowledge, because basically we are not just coming with the numbers, whether those number making sense or not. We just not throwing the numbers. We need to have a economical design. So there are some notes that option 1 is slightly over designed, very slightly over designed. So D was 255 millimeters. If you go back to the calculation of D, if you go back to this calculation of D, based on our assumptions, we found small d was 255 millimeters, right? So for this 255 millimeters has some capacity higher. How? So if you have a, we know that our required depth is 244.37, right? Yep, we calculated this one was 244.37. So that is the required, that is the minimum that we needed. So that was the assumed one. We assume this one, and based on the requirement we got this is the required one. Okay, so if I do these calculations, I can say that 95.8% and 100 take away 90. So it's 4.2% higher, which is slightly higher. That is not an issue, just a quick check. But I also calculate the area of the steel, which was 628 millimeters. So let's say option 1, we have a area 628 millimeters square, right? But then the required area that we calculated was 399.54. We need to provide minimum this one, so we go for 628 millimeters square. So if I do this ratio, that is the required divided by the one that are actually using it, so we can say that about 63.6, 100 take away 63 point, about 36% is a higher value. So ES 36 is 36 point higher than the necessary. So this is a slightly over design of the beam. I think we know these answers, so I put these examples in the beam. But in case if you get very high over designs, you need to do the iterations. Now percentage of steel by volume for the section is, let's say, 628 millimeters square. We calculated those 628 millimeters square for this option 1, that was 628, and the depth and width, I think that's what we accepted. Depth is 300 and width is 150 millimeters. So if I take it, that is 1.39%, which is almost 1.4%, which was we assumed, right? In our loading calculations, when we done the loading calculations, we made the assumption that we made this assumption number 5, which is reinforcement ratio 1.54%. So it's acceptable. We are just verifying all the assumptions. We don't want to any big discrepancy between the assumption and our calculation. So in the self-weld calculations, it is acceptable. In case if this difference is very big, you should use the actual reinforcement and repeat the procedures again and making sure all the calculations are correct. Well, by hand calculations would be very time consuming. I suggest to develop the Excel sheet, where Excel spreadsheets where you can put all these equations and change the numbers. That will be the more economical or less time consuming iterative process. Now C notes, if the beam is to be used repeatedly, like if you are using this kind of beam in, let's say, 100 beams, do you want to use it? And closer and more economical design could be obtained by having a second or third trial assuming different B on D ratio. If you are using lots of many beams, so you can use those trial beams. Now for fire resistance, we can assume this 120 minutes of fire resistance period. I think this is just the typical fire resistance period that we can use for this beam. And if you go to the table 5.4.1a, there is some combinations are given. We have a 2 and 20 bars. So axis distance, if you have different combinations, our width of the beam is 150 millimeters, and for that we have an axis distance of 55. So if I want to find the cover for the fire resistance, axis distance take away bar diameters is basically what we are looking for. This is the axis distance here. So we just have we just want to find this cover, right? So we just need to deduct this bar diameter divided by 2 and this stirrup diameter 10. I get 35 millimeters. So we should provide the cover 35 millimeter for the fire resistance. I think we provided the cover 25 millimeter for durability. If you remember from the last couple of videos, we provided 25 millimeter. That is for durability, protecting the concrete against the corrosion. But probably we should not use 25 millimeters because that not satisfy the fire resistance condition for 120 minutes. So we suggest that we should use 35 millimeter concrete cover that will satisfy the fire resistance and durability. So that's the final answer for these questions, for these examples. Thank you very much.